Let's get started. So today's session is going to be a very important session in terms of the LLM application and the real world scenario where the LLM we are using in the making the chatbots and making the advanced RAG system. And this session is going to be a very important for end-to-end deployment for the LLM application using LangChain. And so today we will be follow this path. So first we have some PDF document, and I will let you know what are the PDFs document we have. So we have two PDF documents here. One is the Mercury outputs and one is the Yamaha engine manuals. So these two both documents are different documents. So these are the service manuals from the water boats. So you can see these are the some configuration from the water boats we have. This is for specifically for Mercury and the Mariner company, and this is for the Yamaha engine manuals. So this is basically contains the information about the how spark plugs works and how water engines, water boat engines has some configuration, probable and rotating parts. So we will be doing building a rack system on these two both of the PDFs, and then we will be building a multi-agent architecture where uh, the our rack system can handle both of the PDFs and can able to answer the question from the both of the PDF. So I will go one by one. So uh, first you have any query, query related to the rack systems until now that we have learned before. Okay, I consider it as yes. So I will start with the Ollama. So you can search the Ollama on your Google Chrome, and this will provide you the local setup for your LLM models. So as you can see, you can click on the download, and you can also download it for Mac OS and Linux, and also for the Windows. So in the model cards, you can pick up any model that you want to run in your local machine. And first you need to take care that you don't download the larger model, because larger model will take you the more memory and the more GPU. So consider the 1 billion or 3 billion models. For example, for this demo, I have considered the 3.2 1 billion model. So it is basically a 1.3 GB model. So what I did, I download the Ollama, and you can see in my machine Ollama is already downloaded, and just I run this command Ollama run Ollama 3.2 1 billion model. So it has pulling some shards and the transformer architecture, and it is now downloaded in my local machine. So as you can see, if I run the Ollama list, so I have only one model downloaded in my local machine, and the size of that model is 1.3 GB, and it is downloaded 2 minutes ago. So the integration of this Ollama is very simple. So what you need to do, you need to import the statements from the LangChain. LangChain Ollama.llms import Ollama. And this is my simple template that I've given here. Let's think step by step and answer my question. First I run this, and here just I have created object of this Ollama configuration, and my model will be Llama 3.2 and 1 billion. And just this chain will be, what will it be doing? First it will, this question will be invoked into this template, then it will pass that prompt to the model, and then model will generate the answer. And so here I got my answer. I can help with that respond in the way. So as you can see, if I also am not connected to the internet, so this particular model is also able to generate answer, or it has been trained to the 2023 till now. So yeah, it is able to generate an answer for you. And uh, this is you can perform this exercise because the OpenAI and all other models are expensive, or you need to add the credit cards and it will take some cost to you. But for this open source model, you don't need to pay anything, and you can uh, run this particular exercise with these open source models. So first first I will take. So the problem you will be facing with the LangChain is that you need to create a particular environment for the LangChain libraries. So when you are working with the real-time project, so you will be getting a lot of issues with the versioning of the LangChain, because the ecosystem that they have built, they have a lot of dependencies of one package to the another package. So I have created a particular environment for this demo. So as you can see, I have activated my conda environment, and if I pip list, so as you can see, the lang chain, these are the specific version that I am using for this exercise. So uh, if it is changed anyhow, so the code I have written here will not work somehow in some cases. So make sure first you need to create an environment in which you have a specific version specified, so you don't get the versioning conflicts here. And then second thing will be, whatever you do in the LangChain environment, there is a traceability that LangChain provides. Is called Langsmith. So if I go on the website of the Langsmith, I need to sign up first. So this is the traceability of what we are doing in the LangChain, how prompts are constructing, how the APIs has been called to a different model, and what type of object we are calling in the LangChain. So today for demo, I've already created a demo rag project. In the demo rag project, you will be see whatever the applications and whatever the request that we are sending here, so it will comes here. See, I have asked how hello, how are you, so you can see all of the prompts and what is happening under the hood. And so we have a called Ollama name 3.21 billion. Our question was this, and render output was it. So this is also helpful with the real-time application, and it will also tell you what is the latency for your response, and what is the start time, and what is your input call for the LLM, and what was the output. And if you get some error, it will also show you how much what is the error that you get when you are calling the LLM. So for setup, you need to do one thing for set up this. You just need to add the in the environment variable, you just need to add the LangChain API key and the LangChain project name, that is a demo reg in my case, and open API key for, because I'm also using the GPT-4o mini for this exercise. So first, you need to install these dependency: LangChain text splitter, LangChain community, LangChain core, and also the other libraries also. Okay, so so we have two PDFs here. One is specifically for the Yamaha engine manuals, and second is for the manual Mercury output. So first we will take care of this service manual for the Mercury. So first I'm checking whether my all of the environment variables are present in my env file. So that's how you are going to get this traceability in the Langsmith. So it helps you to better decode your code and all that stuff. And I'm using here GPT-4 mini model. Uh, you can also use this Ollama 3.21 billion, or whatever suits you and whatever you wanted to use. Okay, so for this particular exercise, you can see I'm using this demo environment. So make sure the all of the versioning of the LangChain remains the same. So my LLM and the embedding models has been loaded into the LLM and the embeddings variables. And for this particular exercise, we are storing our vector data into the ChromaDB. So ChromaDB is Chroma, Phase, Pinecone. They all are same. They have a different functionality, but under the hood, they are doing the same thing. So whatever suits you, you can also use Phase, Pinecone, and other vector store for your RAG system. So basically, first we need to load the PDF loader from the LangChain. So PDF loader, we are using a pipe in PDF loader for this particular. So we have a data service manual Marina Mercury outputs.pdf. So after passing this PDF loader, it will extract the pages from the PDF. If I print out the pages, so as you can see from this PDF file, we have these page content from the each page. So as you can see in the source key, we have a name of the PDF and the page itself and the page and the text extracted from the PDF file. Three cylinder United States, and these all contains the text from the PDFs. If I check the length of this page is, so this particular PDF has 394 pages. So then we are going to split these large text into a smaller chunk size and chunk overlap that I have explained yesterday. So basically, you can set appropriate chunk size and chunk overlap based upon the project requirement and based upon the documents that you are using. So I'm using 1200 and the chunk size and 100 chunk overlap. So for example, if particular page in the PDF will contains the, if particular PDF page 0 will contains the text more than 1200, it will break that chunk size and convert into a chunk size of 1200. So I'm using the recursive character text splitter. It will use the character counts and it will split the text based upon and the separators, the new line separator and the double new line separator. And then we have, I need to run it, and then we are got the all splits from this PDF. So as you can see, uh, so we have a 394 pages from the PDF. So some pages were containing the more than 1200 text size, so it has been resized to the 1200 chunk size and the 100 overlap. So now after performing the text splitter, we got the length of this all splits is 620. So I'm using a vector store here, ChromaDB. I'm just calling the add documents function from that class, and my all documents will be the all splits, and the all splits schema has the same schema. It has a metadata. Metadata contains the PDF name and the pages, and page content contains the text extracted from the PDF. And so as you can see, we are done with this part. We have a source document, and then we have a document ingestion we need to perform, and then we perform the text chunking, and then we perform split into a manageable chunks, that is 1200 and the 500 100 chunk overlap. And then for embedding creation, so embedding creation, we are using ChromaDB, and we have also added the documents into this particular directory, that is Mercury vector DB. So you can see there are 5 to 6 files that locally has been created in my local directory. So now this vector database has been created in my local directory here, and we are performing this part vector similarity search. So for example, if user asks how to change the spark plug in Mercury engine, and I decide I need to get the three chunks that are related to this query. So so for this particular query, how to change the spark plug in Mercury engine. So we are using similarity search by vector. We are doing the same thing uh, that is shown in the diagram. So we have a query, how to change the spark plug. So that query has been converted into an embeddings. Then their embeddings has been calculated the cosine similarity with our vector databases, and we get the top three chunks. Hopefully these top three chunks will has the answers to this question. So as you can see, we are getting the page number 27, 13, and 62. It says that page 27, 13, and 62 contains the answer. And we also, so these are the text that has been extracted. And for this particular, I'm just pulling the RAG prompt from the LangChain. They have already written the best prompt for the RAG application. You can also build at your own. So I'm just importing it, and you can see our prompt look like this. So our prompt has a two input variable in our prompt, that is a context, that is going to be this text, and the question that user has asked, how to change the spark plug in Yamaha engine. And then there is a prompt. So you can see template, you are an assistant for, this is the base prompt, as we are as I told you yesterday. So this, you can call it a system prompt. So our system prompt is, you are an assistant for question answering task. Use the following piece of a retrieved context to answer the question. If you don't know the answer, just say that you don't know. Use three sentences maximum and keep the answer concise. So we got the two keys here, question and the context. So this is our a default prompt I'm using from the LangChain. And then we are passing it to the LLM. So as you can see, we have a I've just created a new function that that will get the context from this vector store, and then there is a generate function that will return an answer for the particular question. So we have a doc content, all of the we are getting from it from the vector store, and just I'm invoking the LLM and just passing these messages from invoking question is equal to state question, and the context is equal to our doc content. If I run this, and so I'm just invoking question, how to change the spark plug in a Mercury engine. So the LLM say to change the spark plug in Mercury engine, first remove the coiling and then carefully remove the old spark plug. Install the new spark plug, ensure they are properly torqued, and then reconnect and high tension spark plug leads. Finally, replace the calling. So as you know, we are getting this response from this PDF of the manual Mariner Mercury PDF file. As you can see, this graph builder that I built it from the LangChain, it is also show you the flow diagram, what is going to happen in in the flow. So as you can see, we have asked the same question, how to change the spark plug in Mercury engine. So for traceability, you can go into the Langsmith, and you will be see. So we got the traceability here, how to change the spark plug. So this was our question that we have asked, and this is the response that we have get it from the OpenAI. So for this particular question, how to change the spark plug in Mercury engine, I have set it the top size is equal to 4. So as you can see, we are getting a 4 chunks from the PDF file, and that the 4 chunks has been passed as a context to the LLM. So as you can see, this is the context that LLM has been saying, and this is the result that LLM has generated. And see, this is the human message that we have sent. You are assistant for question answering task. Use the following piece of retrieved context to answer the question. And if you don't know the answer, just say this is the system prompt that we have formatted in terms of the question and the context. And you can see the context is big, and from the this context and answer, we are getting the answer from the GPT. So does anyone has any question related to the traceability and the normal rag system? So no question at all. Is I'm audible, or is nobody responded?
You are audible.
Okay, so please respond yes or no, like you have other questions related to this traceability and the line chain rag system. Okay, I consider it as no. So after building and this proper rag system, I have converted this all of the things that we have did into the notebook into a one function, that is a Mercury expert. I call it a Mercury expert. You provide it a question, and it will generate you an answer. Uh, what is so see, I have asked the question, what is a Mercury engine? In the traceability, you will be also see the same question, what is Mercury engine? And here I'm also getting the context. I have set it the context limit is equal to 4. So we are getting the 4 text from this PDF, and this is the answer. The Mercury engine refers to the series of output engine manufactured by a Mercury Marine, featuring various specifications such as a horsepower, RPM ranges, and the fuel requirements. So you can also increase the context size here, for example, to 10 or 20, dependent upon the chunk size and the chunk overlap, and how you need to also evaluate after defining your the top k hyperparameter, which top k is giving you the better results here. And then we are going to build another rack system that is for specifically for Yamaha F90 engine manual PDF. So the process will be the same. uh, First you import the LLMs in the embedding model, then you are using chroma db, and you have specified your persist directory to be in your local machine, that is here Yamaha vector db. And then you load your pdf loader, and then you load all of the pages. So this particular PDF contains the 113 pages. It is lower than what we did before. And after splitting this PDF into a small chunks, so we got the 221 chunks, all of the chunks from this particular PDF. And then we are adding it into the vector store of the Chroma DB, and then we are asking the same question here. So how to change the spark plug in Yamaha engine? So here I have set it the top k is equal to 1. I can also increase it to the 5. Currently I'm getting only one documents from the particular PDF. Increase it to the 5, so I'm getting now the 5 documents. So it says your answers to these questions can be into this pages 88, 87, 88, and this is the page content extracted from this PDF. So again, we are pulling the same prompt from the LangChain that has default prompt structure, and we are asking the same question: how to change the spark plug, and it will also give you in a diagram how the flow is working on. And after doing that all stuff, I've also created a one function where I will call it a Yamaha expert. Means if you throw in a query or question related to Yamaha engine, it will give you an answer for that. See, all of the things remains same. It's just my process directory has been pointed to the Yamaha vector TV, and all of the stuff are same. So if I run it, I got the answer to change the spark plug in a Yamaha engine. First, ensure the engine is off and cool. Remove the spark plug wires and use the spark plug sockets. Unscrew the old spark plug, and so this is the answer that we are getting from the LLM. And for traceability, if you getting some error, or if you are not able to explain what is happening in that, so you can always go to here smithlangsmith.com. It will tell you how this retriever system is working. Our question was, what is a Mercury engine? We get the top 4 chunks from the PDF, and then we are passing that formatted prompt to the GPT. So as you can see, this is the formatted prompt. This was our template, and this was our question. This is the context, and this is the answers from the AI. And we are using GPT-4o mini here. So as you can see, when I ask the hello, how are you, with the Llama 3.2 billion, so latency was big, 3.89 seconds. When I used the GPT-4o mini, so the was very low, because we are using the Llama 3.2 billion in our local machine, so it will be as slow as compared to the paid models out there. And it also has ability to count the how much dollars it will take. It will also count for the token limit and the error rate, streaming latencies, and the first token. And then we are going to see, so these are the two functions that we have created: Mercury expert and the Yamaha engine. So basically Mercury engine and Mercury expert are only able to provide you an answer for this Mercury engine. But if we want to combine this part and create a multi-agent architecture where this case is handled by an LLM, the base LLM, and it will take care of these both of the function, and it will automatically select the appropriate agents, whether I want to use the Mercury expert or whether I want to use the Yamaha expert. So as you can see, for this I have created this tool.py file. In the tool.py file, you can see there are two assistants we have, both Mercury assistant and both Yamaha assistant. So the code remains same here, that we did into the Jupyter notebook. So it will take the query and it will return you the answer for a particular question. So this LLM base agent is defined here. So I will go one by one what is going on here. So first we have GPT-4o mini model loaded from this LangChain library, and then we are taking two arguments, message and history. So message will be two type. One is the AI messages and another one is human messages. So and history will be added into a list of history, so that LLM can understand what the user has asked before, and based upon the history that we have provided to the LLM, it take decisions better uh, on the follow-up question and also on the independent question. So these are the two arguments that we are using here, and you can see we have declared here functions, format tool to the OpenAI functions, F for tools in the agents. So these we have declared the two agents here. Agents is a list that has the two agents, both Mercury assistant and both Yamaha assistant. So I'm using a tool decorator here from the LangChain. LangChain tools import the base tool and the tools. So a normal function does not have this decorator. So this decorator make it very accessible to the LLM. So they have written some decorator functions under the hood, and if you call it once the function, it will run the asynchronously in the Python. So for declaring the agents and tools in the lang chain, you just need to use this decorator and your function will remain the same. So this function remains the same. So I will change it a little bit. So currently we do have two tools, and I'm importing these agents into the multi-agent.py. So if I go into the multi-agent py, I'm importing the from tools.py import the agents, and I'm just converting these agents into the OpenAI functions. So means these docstring will be used as a LLM prompt. So if LLM needs to understand which tool I need to use, it will also look here. So this both Mercury assistant function takes the user question and the detail description of the user question related to the Mercury and Mariner output bot engine. It provides an solution, and I will remove it for now, and references related to the Mercury and Mariner output boat engine issues. So this tool is very helpful if the question is specifically related to a Mercury and Mariner output engines, and also important for the engine parts. So as you can see, this detailed docstring has been used in LLM to classify the things. So as you can see here, both Yamaha Assistant has also the same doc string. So it will also use the this doc string to classify the question. And then I'm using this multi-agent prompt here. So you can call it a system prompt because I have also declared it as a system prompt. So if I go into the my multi-agent prompt, you are an AI assistant chatbot working for Tatra's data. You will receive a diverse range of question spanning the water boards and the YouTube expert also. Use the appropriate tools to provide an accurate and the relevant answers to the user question. So as you can see, we have added these two tools for now, and in future we are also adding the YouTube search. So for you can also say that does ChatGPT provides you the YouTube links and all that stuff? No, it will not provide you the YouTube links and the web pages references. So for adding that, we need to add one tool that will be taking the user question and it will return the YouTube video URL links so that user can click on the YouTube video and watch that video related to the any uh, engine issues that they have. So any question related to the agents as of now?
No, sir.
Okay, so okay, so I will just run this the multi-agent dot py, and you can see I'm using the agent executor class from the lang chain, and that has also added the self-taught chain, and the tools are the agents that we have here, and I'm just also returning the intermediate steps, and then we are declaring the AI messages and human messages and the system messages to the LLM. So yesterday I was talking about the human messages, system messages, and the AI messages. So based upon that, our LLM model take decisions, right? So after taking the decisions, we need to add. For example, It will be better. I will if I show you the graphical user interface of this multi-agent architecture. So see, this is the chat interface that I've made. If I So it says, hello, how can I assist you today? If you have any question about boats, engines, or anything else, free feel to ask. So what we did, we have already built it a two rack system, which is one rack system is expert in Yamaha engine and one rack system is expert in Mercury engine. So it will handle both of the cases. So for example, if I ask how to, so this particular question is related to the Yamaha engine. So I'm entering the agent executor chain, and it has used this Yamaha boat assistant. The question was how to change the spark plug in Yamaha engine, and see, we got our answer. So this answer has been, we are getting this answer from the Yamaha engine assistant. So see, we have a two agents. If my question is related to the, so this is the tool, both Mercury assistant. If I ask the same question and change the engine name Yamaha to engine, so see, it has used this both Mercury assistant with question how to change spark plug in Mercury engine. So again, we are getting our answers You need to follow this step. Safety first, remove spark plugs, unscrew the old spark plug, install the new spark plug, reconnect the spark plug leads, and test the engine. So this is our whole rack system and the multi-agent architecture. So you can also add more agents to the LLM, but there is also one limitations here. If you add more agents here, so LLM can also gets hallucinated sometimes. So I will assist you, like it can handle the 6 or 7 agents right now, the GPT-4o mini. You can add more than that, but 6 and 5s are appropriate numbers for now for adding the agents to the LLM. So any questions far away, so we will proceed to next. And here also you can see the intermediate steps that has been taken by the LLM. So the intermediate steps will tell you how this boat Mercury assistant has been used, and this boat Yamaha assistant has been used. So I asked the question to the Yamaha engine, I got the from the Yamaha expert, and if I asked the question from the Mercury engine, I got the answer from the Mercury expert. So this, so you will be, I will share with this with you, and I think you will be able to run this on your local machines using the Ollama, and you are able to build the multi architecture agentic systems. And this will goes with the chatbots. So if you are making some chatbots which are able to recommend you products, for example, there is Amazon and Flipkart, they do have also a chatbot where if you ask some query related to the products, so they will also recommend you some products. So you can also add recommending products agents to the LLM, and you can connect that agent to your databases like SQL and MongoDB. And if user is asking about the products, so you will get the response from the databases, and that database response goes to the LLM, and then LLM will generate you the appropriate recommendations products. Okay, so yeah, that's it for the building the RAG system from scratch to the development. Any question related to the rack system or LangChain? Yeah, Harsh, I can share this notebook for reference.
Okay, thank you, sir.
Yeah, so are you able to understand what is happening behind the LLM?
Yes, sir. I am actually this is my first class, and I'm
Okay, is it your first class? I think you're not audible. Can you speak some loudly? uh,
okay. This is my first class.
right.
I need to watch the recorded lecture, but yeah, this lecture is quite good. And one thing, sir, I need to ask, like, you create two engines.
Right.
So, like, if I ask something for that, I need to define the like I need to tell that I use Mercury engine and the another one, or it will like give me automatically.
You it will give you automatically, like you need to specify. For example, if I do have a car of Toyota, so I will ask the chatbot that I have a Toyota car and I need to wash that car, right? So
Right, sir?
user will always specify whether they had to have a Maruti Suzuki car and the Toyota and the another branded car. So based upon that intention, LLM will classify which tools has been used, and LLM also take reference these doc string. Whatever you have written in this doc string, it will try to capture that. So LLM does not know about the code here that has written.
Okay.
It only knows this thing. This bot Yamaha assistant function will take the user question, detailed description about the user question related to the Yamaha boat engine. So LLM only will understand this part. It has nothing to do about this function.
Okay.
And as you can see, I will also give you one example. For example, YouTube search. So for I have not added until now, but if I add it, so I have added this search YouTube. So what happened here? So this YouTube search has been added, but I have not given defined the detailed descriptions of this YouTube search, right? So I need to specify the more information. So if I define this information, YouTube search function will take the user question about Yamaha engine and the Mercury engine, and it will provide you the. So this is basically a prompt engineering that we do. This tool is very helpful if the user question is related. Okay, so I will remove this part.
So, sir, is there any way to like write this prompt in a proper way, or like we can write it randomly? Like,
You can change the prompt a little bit. For example, I'm changing right now, so
yes,
we will see the results.
okay,
After evaluating your agent architecture, we will see the results, how it
okay,
is performing.
right,
Because LLM will not give you a right answer always.
right, sir,
I'm going to refresh it. So see, now it has used the YouTube search because my this description is very precise, right?
right,
So I'm getting my YouTube links for this particular video.
okay, great,
So you can change it little bit, but this ability of LLM increases the you know, you can add anything like you can add anything, you can code anything down there, and you can add any tools and the agents to the LLM. And there is also one platform that I wanted to know you, Perplexity AI. So if you ask some question like uh, let's ask related to the transformer architecture. See, I have asked the question and it has also give me a sources, like sources that also the Google also provide these sources, right? So if I goes on, if I create a new thread, and focus will be my videos. If I click on the video, so I will also get the YouTube videos here. See, I need to learn the transformer architecture of encoder and decoder. If I show the all of the resources, so I'm also getting the YouTube videos here. Essentially, they are also doing the same thing. Uh, they are also doing the same thing that we did here, and they have generated the 5 billion revenue this year. I think more than that, I don't know, but did they have done the same thing. They have added the different agents here at the back end, and they are providing you the sources and with the YouTube videos.
Okay, perfect.
So I will be sharing any question related to this thing.
Okay, sir.
Anyone?
Sir, someone asked a question, how can we improve the accuracy in rack system?
See, rack system, we can further increase it to the next level, right? So we can add one thing here when we are searching our query, like how to change the spark plug, and we are getting some source documents from the vector databases, right? For example, we are getting 10 documents, and for that 10 documents we can also apply some re-ranking, and based upon the re-ranking it discarded those documents that does not contains the answer. So after cleaning or re-ranking the chunks, we discarded the 5 chunks, and after getting the 5 chunks we are only providing the context of the 5 chunks to the LLM, and it will generate the precise and the concise answer for that. There are a lot of ways to improve it. You can also use the graph based approach, where rather than extracting the simple text, you can extract the entities and relationships from the text and stored into a vector databases. So that could be another way. And yeah, there are many ways to do it, but this is the simplest way you can start with, and you can learn it very easily. And for further enhancement you can do at your own thing, and you can also evaluate at your own which approach has been working uh, towards you, right? Okay, I will stop the recording.